everyone, welcome back to Quantitative Reasoning. Today we're in section 6.2, linear equations in one variable and proportions. So our objectives for this video are to solve linear equations, both regular ones and ones that contain fractions, and we're also going to solve proportions, and then some word problems that use proportions, and we're going to learn how to identify equations that have no solution or infinitely many solutions, because they're a little different from the ones that have a single solution like we'll do in this first objective. So let's get started. So what do we mean when we say linear equation? Like exactly what is a linear equation? So a linear equation in one variable, which we'll use x for our variable here, that's an equation that can be written in this form. ax plus b equals 0, and the rules are that a and b both have to be real numbers, and a cannot equal 0. And the reason we have this rule here that a cannot equal 0 is because you can imagine if a could equal 0, then 0 times x would make 0, and this term would disappear from your equation, and then you wouldn't have a variable anymore, so that wouldn't be a linear equation. So as long as you've got an x term and a constant, and your a and your b are both real numbers, then you've got a linear equation. Now, if you have an equation where the variable is x, then to solve that equation means to determine all the values of x, your variable, that will give you a true statement when substituted into the equation. So any number that makes the equation true is called a solution or a root of the equation. Now with linear equations, there's almost always exactly one solution or one number that makes the equation true, but it's also possible that there could be an infinite amount of values that make the equation true. Either way, whatever values make the equation true, those numbers form a set, and that set is called the solution set. So for a linear equation, the solution set could contain one number, or it could contain an infinite amount of numbers, or, as we'll see later, it could contain no numbers. It could be the empty set. Now, two or more equations that have the same solution are called equivalent equations. And it's this idea of equivalent equations that's going to help us isolate the variable, which is how we'll know what the solution is. So the idea when you're solving an equation is to do the same thing to both sides of the equation. So the expression on the left and the expression on the right, we want to do the same thing to both of them, so that basically we just have the same equation but in a simpler form. In other words, we have an equivalent equation that is simpler. So our first property that's going to help us with that is called the addition property of equality. And all it says is the same real number or algebraic expression may be added to both sides of an equation without changing the equation's solution set. So if you start out with an equation that says a equals b, for example, and it doesn't matter what a and b are, but you just know that whatever a is, it is the same as b. Then if you add c to both of them, then you now have an equation that says a plus c equals b plus c. So these two are equivalent equations. In other words, they have the same solution. And then we have another property of equality, and this is the multiplication property of equality. And this says the same non-zero real number may multiply both sides of an equation without changing the equation's solution set. So again, if we have an equation that says a equals b, we can multiply both sides of the equation by c, and then we know that a times c equals b times c, as long as c is not 0. Now see, you cannot multiply both sides of the equation by 0 and get an equivalent equation, because anything times 0 is 0. So at that point, all bets are off. But you can multiply both sides of the equation by anything besides 0 and still have an equation that has the same solution. So those two properties are really helpful when we're trying to solve an equation. So here is the process we're going to use to solve a linear equation. Now keep in mind that not every step is necessary on every equation, but if you need a step, this is pretty much the order that we like to go in. Step 1 would be simplify the algebraic expression on each side of the equal mark by removing grouping symbols and combining like terms. So you know that the way to remove grouping symbols is going to be to distribute if you need to, and then you know how to combine like terms. You just add or subtract the coefficients. Once you've got the expression on each side of the equal mark as simple as possible, the next thing is going to be to collect all the variable terms on one side of the equal mark and all the constants or numerical terms on the other side of the equal mark. And then you'll just isolate the variable and solve. And usually at that point, what we mean by isolate the variable is either divide or multiply both sides of the equation by the same thing so that the expression on one side of your equation is just x, just plain x. At that point, you'll have the equation solved, and you'll just want to check the solution that you found in the original equation and make sure that it really is the correct solution. In other words, you're trying to find out if you made a mistake anywhere. Okay, let's get an example for ourselves. So this is example 1, and it says solve and check the equation 2x plus 3 equals 17. Okay, so first I want to point out to you that you always need to read the instructions and know for sure what they're asking you to do before you just start doing stuff based on how the problem looks. The instructions here say solve and check, so we will do both. And now let's look at this equation. So remember, when we're solving an equation, we're ultimately trying to isolate the variable, but we do that by first making sure that the left expression and the right expression are each as simple as possible. And then we add or subtract the same thing from both sides so that the variable term is isolated. And then we multiply or divide the same thing on both sides so that the variable itself is isolated. So first, let's look at the expression on each side of the equation separately. I don't see any parentheses here or any terms that need to be combined, and I don't see anything like that on the right side either. So I'm going to go ahead and say that the first step in our solving process really did not need to be done. It's already done for us. Okay, the second thing is we want to isolate the variable term. So I want to eliminate this plus 3. The way to do that is to add something to both sides that will make this term and the new term add up to 0. So the way to eliminate plus 3 is to put minus 3 on both sides. And so that's what I've done here. I've just recopied the problem, and now I have put minus 3 on both sides, and then we'll combine our like terms. On the left side, I've still got my 2x, but the plus 3 and the minus 3 are going to add up to 0. So now the expression on the left just says 2x. Then I've got my equal mark, and we'll combine terms on the right side, and we know that 17 minus 3 is 14. Okay, this is now our new equation that is equivalent to the original equation we started with. And so we'll continue solving this one. So now what we want to do is eliminate the coefficient of 2. So this is 2 times x. So the way to eliminate this coefficient of 2 is to divide both sides by 2. So I'm going to divide the left side by 2 because that's what's going to make that coefficient disappear. And because I did that to the left side, I also have to do it to the right side. Okay, now on the left, 2 divided by 2 is 1, so that leaves me with 1x on the left. That's what we wanted. And then our equal mark. And then on the right, 14 divided by 2 is 7. So we think the solution to this equation is 7. That's what our work showed us, but now we need to check it. So the way to check is to take the 7 and replace the variable with the 7. So I'm going to have 2 times 7 plus 3 equals 17. And I just need to evaluate the left side and make sure that it matches the right side. So at this point, we're using order of operations. So we know that 2 times 7 is 14. So now we have 14 plus 3. And then 14 plus 3 is 17. So the left side does match the right side, and that tells us that 7 is the correct solution. In other words, 7 is the only number in the solution set. Now, keep in mind that in my lab, they're not going to have you type x equals 7. In my lab, what they will do is they'll put this on the screen for you. It will say the solution set is, and then it's got these curly braces. Now, you remember those from when we talked about sets, and all you need to do is type the number in here that is a solution to the equation. So you're just going to type 7 in there. You're not going to type x equals 7, just the number that belongs to the solution set, okay? Only type the solution in the braces, not the variable. And here's example 2. So this one also says solve and check the equation. And here we have a little more complicated equation. And you can see that on the left side there is some simplifying that could be done. We need to eliminate these parentheses before we start solving. So we need to eliminate the parentheses by distributing the 2. And then we'll have some like terms to combine. So let's go ahead and distribute this 2. 2 times x is going to give us 2x, and then we have a minus, and 2 times 4 is going to give us 8, and then we have our minus 5x that's still there, and then we have the right side of the equation, which is equals negative 5. Always keep both sides of the equation together. Don't do your work so that you're bringing one side of the equation down and then leaving the other one off. You need to always, on every line, have the entire equation all together, because what you've got here is an equivalent equation to the one we started with. So now that we've eliminated the parentheses, we're ready to combine like terms. Here I have a 2x and a minus 5x. We know that 2 minus 5 is negative 3, so that's going to give us negative 3x, and then we've still got our minus 8, and then we've still got equals negative 5. Okay, now when I look at the left side, it has an x term and a constant. It cannot be simplified further. The right side is just one constant, so of course it also cannot be simplified further. At this point, we're ready to start solving by either adding or subtracting the same thing on both sides of the equal mark. Remember that our goal is to isolate this variable term. So I want to eliminate this minus 8. The way to eliminate minus 8 is to add 8. So if I want to add 8 to the left side so that this minus 8 term disappears, I will also need to add 8 to the right side. You can add whatever you want as long as you add it to both sides. And the thing you want to add is always the opposite of what you start with. So I had minus 8. In order to eliminate it, I need to put plus 8, but I had to put it on both sides. Okay, now combining like terms on the left. The minus 8 and the plus 8 add up to 0. So all that's left on the left side is the negative 3x. Then I've got my equal mark, and then on the right side, negative 5 plus 8 adds up to positive 3. Okay, at this point, we are ready to eliminate the coefficient. So the way to eliminate a coefficient is to divide both sides by whatever that coefficient is, because any number divided by itself is 1. So what we're going to do is divide the left side by negative 3. Now keep in mind, it's a common mistake for people to get this step confused with this step. See, up here, I had to add the opposite to both sides. Down here, I don't want opposite signs, because if I have a negative in the top and I divide by a positive, that will still leave me a negative coefficient. I don't want that. I need to divide by whatever the coefficient is. So if the coefficient is negative 3, so my term is negative 3x, in order to isolate the x, I need to divide by that exact coefficient. So I've divided by negative 3 here. That means I need to divide by negative 3 on the right side as well. Now look what happens on the left. negative 3 divided by negative 3 is positive 1. So now on the left, I've got 1x, which is just written x, you know that. And then I've got my equal mark, and then 3 divided by negative 3. Okay, 3 divided by 3 is 1, but I've got a negative here. Positive divided by negative is negative. So this is going to reduce to negative 1. Okay, so the solving part is finished. We think we've solved it, and we think the correct solution is negative 1, but let's check our work. So we're checking negative 1. So I am going to write this same equation over again, but where I had a variable, now I'm going to write negative 1 in its place. So 2 times parentheses, negative 1 minus 4, close parentheses, minus 5 times negative 1 equals negative 5. Okay, now once you get your solution substituted in there, you're just going to simplify each side as an order of operations problem. So if you look at this, we do have parentheses here, and there's something we can do inside these parentheses. So we know that negative 1 minus 4 is going to be negative 5, and then I'm just going to keep the rest of the left side as it is. Okay, now we're ready to do the multiplication part of our order of operations. So we know that 2 times negative 5 is negative 10, and then we know that negative 5 times negative 1 would be positive 5, and then negative 10 plus 5 is negative 5. So the expression that we have on the left, when we substitute this negative 1 in here, simplifies down to negative 5. And that is an exact match for what we had on the right without doing any extra work. So now we can see that the two sides are the same. That means negative 1 makes the equation true, and that means negative 1 is a good solution. So now we would say in my lab, the solution set is, and we would just type negative 1 inside the curly braces. And here's example 3. So this one says solve and check the equation 5x minus 12 equals 8x plus 24. Now what's different about this example is that this is the first time we've had a variable term on both sides of the equal mark. Now when you look at the expression on the left, there's nothing you can do to simplify that. There's no grouping symbols that we need to remove, and there are no like terms to combine. Same thing on the right, no grouping symbols and no like terms. So our first step in our solving process is complete. So now it's time to collect all of our variable terms on one side of the equal mark. Now the way that we do this, we can either do minus 5x on both sides, or we could do minus 8x on both sides. Now think about it. If I put minus 5x on both sides, then over here, 8x minus 5x is going to give me a positive number. But if I put minus 8x on both sides, it's not wrong, but it will force me to have a negative coefficient over here. 5x minus 8x would be a negative x term. So I like to keep the x coefficients positive. You can do it either way you want to. I'm going to go ahead and put minus 5x on both sides. And now we're going to combine like terms on both sides. So on the left, 5x minus 5x is going to add up to 0, and I'll just have negative 12 on the left side, then our equal mark. And on the right side, 8x minus 5x combines to give us 3x, and then we've got our plus 24. So this is our new equivalent equation that has the same solution as the one we started with. And we've got now just one x term, so we want to isolate this x term. So we'll have to do minus 24 on the right in order to make that happen. And if we say minus 24 on the right, we will also say minus 24 on the left. So let's go ahead and put that. Okay, now simplifying on the left side, negative 12 plus negative 24 is going to add up to negative 36. Then we've got our equal mark right here. And on the right side, we've still got our 3x, and the positive 24 and the minus 24 add up to 0, of course, so that constant term disappears, which is what we wanted. Okay, now we want to complete the solving process by eliminating this coefficient. So we will divide both sides by 3 because that's the coefficient here. So dividing both sides by 3. On the left, negative 36 divided by 3 is negative 12. And on the right, 3 divided by 3 is 1. So that just leaves x, or 1x here. So we think our solution is negative 12. That's what we found. And now we want to check that. So again, go back to your original equation, and wherever you have a variable, just write in the solution that you found. So 5x minus 12 is going to become 5 times negative 12 minus 12. And then on the right side, 8x is going to become 8 times negative 12, and then we've got our plus 24. And we just want to simplify both of these expressions and make sure that they come up with the same number. So 5 times negative 12 is negative 60. So on the left side, I've got negative 60 minus 12, and that adds up to negative 72. And on the right side, 8 times negative 12 is negative 96, and negative 96 plus 24 also adds up to negative 72. So that tells me that negative 12 does make the equation true, and that tells me that negative 12 is the correct solution. So negative 12 is what you would type as the solution set. Okay, here is example 4. And this says, again, solve and check the equation. We have 2 times parentheses x minus 3 minus 17 equals 13 minus 3 times parentheses x plus 2. Okay, just like we saw before, the first thing we need to do is make each expression as simple as possible. So before we start adding and subtracting the same thing on both sides, we need to distribute and combine like terms on both sides of this equal mark. So on the left, distributing this 2, we're going to get 2 times x, which is 2x, minus 2 times 3, which is going to be 6, and then we've still got our minus 17, and then our equal mark. And now we're ready to distribute on the right side, but remember, we're distributing a minus 3 here. So remember what happens when you distribute a negative, it causes these signs to change. So we're still going to have our 13 here, but when we do minus 3 times x, we're going to have minus 3x, and when we do minus 3 times 2, we're going to have minus 6. Okay, now the grouping symbols are gone, but I still see terms on the left that need to be combined. So minus 6 minus 17 will combine and give us minus 23. Then we've got our equal mark. And on the right side, I have a positive 13 and a minus 6. So 13 minus 6 is 7. So we're going to have 7 minus 3x. Okay, now it looks very much like example 3 did. So in this case, we want to think about how we can eliminate one of these x terms and have the result come out with a positive coefficient. So I think if we add 3x to both sides, that will eliminate the x term here, and then 2x plus 3x would give us a positive 5x. So let's do that. Okay, so 2x plus 3x is 5x, and then we still have our minus 23, and then our equal mark, and then 7, and then the x term here disappears because minus 3x plus 3x disappears, adds up to 0. Okay, now we're ready to start isolating the x term. So we want to eliminate this minus 23. So let's add 23 to both sides. That will give us on the left side 5x, then our equal mark, and then on the right side 7 plus 23, so that's 30. Okay, now we have 5 times x equals 30. So we want to eliminate this coefficient, so we'll divide both sides by 5. Then we have 5 divided by 5, which is 1. So we have 1x on the left side. And on the right side, 30 divided by 5 is 6. So we think our solution is 6, and now we just want to check. So I'm going to copy 6 into my original equation. Everywhere I had a variable, I'm going to copy 6 in there. So it's going to be 2 times 6 minus 3 minus 17 equals 13 minus 3 times parentheses 6 plus 2. Okay, let's do parentheses first. On the left side, 6 minus 3 is 3. So we'll have 2 times 3 minus 17. And then let's go ahead and stay on the left side. 2 times 3 is 6, so now we have 6 minus 17, and that adds up to negative 11. On the right, 6 plus 2 is 8, so we'll have 13 minus 3 times 8. Then we know that 3 times 8 is 24, so we'll have 13 minus 24, and then that adds up to negative 11 as well. So since the two sides match, that tells me that 6 was the correct solution, so I would say the solution set is 6. Now we're going to look at some equations that contain fractions. Now keep in mind, equations are so much easier to solve when they do not contain fractions. So what we're going to learn to do is not get along with the fractions, not learn how to handle the fractions, but learn how to eliminate the fractions. And so what we're going to do is remove the fractions by multiplying every term by whatever the least common denominator would be. We're not going to get a common denominator. We're just going to figure out what the common denominator would be, and then we're going to use it to knock out all the fractions. You'll see what I'm talking about here. So let's take a look at example 5. It says solve and check the equation 4x divided by 5 equals 5x divided by 3 minus 13. And you can see here that our two denominators are 5 and 3. And so the common denominator, if we had to do a common denominator, the common denominator would be 15. So I'm just going to write that down here. Okay, now I'm going to recopy my equation big enough where I can work on it. So what we want to do here is use the 15 as a multiplier. Remember, we can multiply both sides by whatever we want as long as we multiply both sides by the same thing. And since the common denominator is 15, that is the smallest number that both 5 and 3 can go into. That's what it means to be the least common denominator, or the least common multiple. So what we want to do is use 15 as our multiplier. And I'll just multiply the entire left side by 15 and multiply the entire right side by 15. And of course, the first thing we have to do after we multiply the right side by 15 is we have to distribute to eliminate those parentheses. These parentheses I'm not worried about on the left because they're just really a multiplication symbol. But since we have two terms on the right, these parentheses show me that I have to use the distributive property here. So I'm going to keep the left side exactly as it is, and I'm just going to distribute the 15. So 15 times 5x over 3 is just that, and 15 times minus 13 gives us that. All right, now let's go back, and what you're going to see is that the 15 helps us cancel out all the denominators. That's the goal. So 15 divided by 5 is 3. So what I have here now is 3 times 4x. You see that? The 15 divided by 5 simplifies to 3. And that's how we get rid of our denominators. Then I've got my equal mark. Now over here on the right, 15 divided by 3 is 5. So that 5 times this 5x. You see that? 15 divided by 3 is 5. And then we've still got a 5x here. And then we've got our 15 times 13, which I'm just going to keep the same for this step. Okay, now see, all the denominators are gone. That's what we wanted. So I want you to catch on to this really and practice it if you need to, if you're unfamiliar with it. But let's just talk about what we did. We looked at the equation, we figured out what the common denominator would be. We said the common denominator would be 15. But we didn't use the 15 as a denominator. Instead, we multiplied both sides by 15. And since both 5 and 3 can go into 15, that allowed us to cancel out the denominators. Okay, now we're ready to simplify each of these expressions. So here we have 3 times 4x, that's going to be 12x. Then our equal mark. Then 5 times 5x is going to be 25x. And now we have to do this multiplication. So you might want to do it on a calculator, that's perfectly fine. But 15 times 13 turns out to be minus 195. Okay, now we have a 12x equals 25x minus 195. This is an equivalent equation to the one we started with. It's just so much nicer because it doesn't have any fractions. But we do need to eliminate one of these x terms. Now, since the right side already has the constant, that means I need to collect my x terms on the left side. So I'm going to put minus 25x on both sides. Even though that is going to cause me to have a negative coefficient for my x, it's kind of necessary here because it wouldn't do us any good to say minus 12x on both sides because that would leave the left side empty. You don't ever want to leave one side completely empty when you're solving a linear equation. So I knew that I had a constant here, and so that meant that I wanted to eliminate this x term. So I put minus 25x on both sides. Now 12x minus 25x adds up to negative 13x. And then on the right side, the 25x minus 25x adds up to 0, but I've still got minus 195 here. Okay, now let's divide both sides by this coefficient. So we're dividing both sides by negative 13. The negative 13's on the left divide out and leave us with a 1. Negative 13 divided by negative 13 is 1. So I have 1x on the left. And then on the right, we have negative 195 divided by negative 13. And on a calculator, if you punch that in, you can find that that's equal to 15. Okay, now you might think it's going to be a whole bunch of work to check this 15, but it won't be as much work as you think, because actually the fact that we have denominators here is going to help make it easier for once. So I'm going to copy the 15 in place of the x into my original equation. So it's going to have 4 times 15, all divided by 5, equals 5 times 15 divided by 3, minus 13. Okay, we'll come over here and we'll use the same simplifying trick that we used over here when we were solving. 15 divided by 5 is 3. So that's going to leave me 4 times 3 on the left side. And we know that 4 times 3 is 12. On the right side, 15 divided by 3 is going to leave us with 5. And so that'll be 5 times 5. Then we still have our minus 13. And we know that 5 times 5 is 25. And then 25 minus 13 is also 12. So that does check out, and that means 15 is the correct solution for this equation. And here's example 6. This is very similar to the one we just did. So if you want to stop the video and try this one on your own, I think that's a great idea. And now if you've had a chance to do that, I'm going to go through it with you. So we have y divided by 3 plus 2/5 equals y divided by 5 minus 2/5. So rather than wrestle with the fractions, what we want to do is eliminate the denominators by choosing a multiplier. And you can see that if our denominators are 3 and 5, then the least common denominator would be 15. So we will not use the 15 as an actual common denominator, but we will use it as a multiplier to eliminate these denominators. Now watch what I do here because I'm going to save you a step. Instead of putting parentheses around the entire left side and multiplying that by 15 and then the entire right side, and the next thing we would have to do is distribute. Instead of writing it that way, I'm just going to pre-distribute, so to speak. So watch how I do it, and you can do it too. So I've written down my equation, and I've left myself plenty of space because I already know I'm going to be distributing 15 through here and 15 through here. So I'm just going to go ahead and put times 15 in front of each term. And it's as simple as that. And so now my distributing is already done, and all I have to do now is simplify. So you can see that 15 divided by 3 here is going to leave us 5. So that term will be 5y. And then on the second term, 15 divided by 5 will be 3. And so this term will be 3 times 2. On the other side of the equal mark, 15 divided by 5 is 3. So this term will be 3y. And then here, 15 divided by 5 will be 3 again. And so that will be minus 3 times 2. Okay, now let's do the multiplication that we see here. So 3 times 2 is 6 in both cases. So I'll have 5y plus 6 equals 3y minus 6. And now we are ready to start solving. Now all of this up here was not really solving, it was just simplifying, getting ready to solve. Now we can solve, which means to isolate the variable term and then isolate the variable. So notice we have variable terms on both sides of the equal mark. I'm going to choose to say minus 3y on both sides of the equal mark. On the left side, 5y minus 3y will add up to 2y, and then I still have my plus 6 here, then my equal mark. And then on the right side, the y terms add up to 0, so all that's left on the right side is negative 6. Okay, now to isolate the y term, I need to eliminate this plus 6, so I need to say minus 6 on both sides of the equal mark. And then over here on the left, plus 6 minus 6 is 0, so the left side now just adds up to 2y. On the right side, I have minus 6 minus 6, so that adds up to minus 12. And now we're ready to isolate the y, so we'll divide both sides by 2. And then 2 divided by 2 is 1, so this leaves me 1y on the left side. On the right side, negative 12 divided by 2 is negative 6. So we think our solution is negative 6, but we do need to check it. So let's go ahead and write negative 6 in place of each variable. So we'll have negative 6 divided by 3 plus 2/5 equals negative 6 divided by 5 minus 2/5. Now I'm going to walk through this with you with the fractions, but I do want you to know that at this point you can take your calculator and punch in negative 6 divided by 3 plus 2 divided by 5 and get a number there. Or you could even do it in fraction form, because your calculator that you're allowed to use, your TI 30X2S, has a fraction button on it. So learn how to use that. If you have not seen the video that I have posted for you in Canvas that shows you how to use the fraction functions on the calculator, you need to go watch that. It'll be very helpful to you. So, but I'm going to go ahead and walk through the fraction operations with you here. So because we are only working with one expression at a time, so we're keeping the left side separate from the right side while we check, I can't multiply both sides by 15 here because I don't have both sides to work with. I really, in this case, do have to get a common denominator. So what I'm going to do is I'm going to say I need a common denominator of 15. So how can I change a 3 to a 15? Just multiply it by 5. But that means I need to multiply by 5 in the top. Over here, plus 2/5, I need to change that 5 to a 15. So how do you change a 5 to a 15? You multiply by 3. Okay, now that gives me negative 30 over 15 for the first term, and positive 6 over 15 for the second term. And then negative 30 plus 6 is negative 24 over 15. Both of these numbers can be divided by 3, and so 24 divided by 3 is 8, and 15 divided by 3 is 5. So it leaves me with negative 8 over 5 for the left side. Over here on the right side, we already have a common denominator, so it's much easier. So let's say negative 6 over 5 minus 2 over 5. Because the denominators are the same, all we have to do is combine the numerators. So negative 6 minus 2 is negative 8, and it's over 5. And so the two sides do match, and that tells us that our negative 6 solution was correct. Okay, now example 7 is another equation that has denominators, but what's different here is that the top of these fractions is not just one term but two terms. So I want to show you how to deal with that. It's the same approach, it's just when you get to the distributing part, you handle it maybe a little differently. So you have to be a little more careful. So let's go ahead and figure out what our common denominator would be here. So our denominators are 5 and 4, and the smallest number that both 5 and 4 can go into is 20. So our common denominator would be 20, but what we want to do is use that 20 as a multiplier to eliminate the denominators. So now what I'm going to do is go ahead and copy my equation over again, but leave plenty of space, and I'm going to pre-distribute that 20. So I'm going to multiply each term on the left by 20 and then the term on the right by 20. This fraction is one term. So when I multiply everything by 20, look what happens. So first term times 20, second term times 20, the term on the right times 20. I want you to notice, I want to point this out to you, that even though the 1 did not have a denominator, I still had to multiply it by 20, because the rule that we're using here is we can multiply both sides of the equation by anything we want as long as we do it to both sides. And so I had to multiply everything on the left side by 20, including the 1. So don't let that alarm you. A lot of students don't want to multiply by the least common multiple here because I think their reasoning is this doesn't have a denominator, so it doesn't need it, but it does. So now that we've done that, let's go ahead and simplify. Our 20 divided by 5 will reduce to 4. So that's going to eliminate the denominator, and we'll just have 4 times x minus 3. But see, I left that in parentheses because I do have to multiply the entire x minus 3 by 4. Okay, here in the second term we have minus 1 times 20, so that's just minus 20. And then over here on the right side we have 20 over 4, or 20 divided by 4, and so that's going to be 5. So I'm going to have 5 multiplied by this entire parentheses. So 5 times x minus 5. Now I can just distribute the whole numbers. So 4 times x minus 3 is going to be 4x minus 12. I've still got my minus 20 here. And then distributing the 5, that's going to give us 5x minus 25. Okay, I notice that I have like terms on the left, so let's combine those. That gives us minus 12 minus 20, and so that's going to be minus 32. So 4x minus 32 for the left side. And on the right side, there's nothing to combine. Now we're to the point where we have an x term on each side and a constant on each side. We have to decide which x term we want to eliminate. Remember, we like to leave our x term with a positive coefficient, so I'm going to choose to subtract 4x from both sides. On the left side, 4x minus 4x is 0, so that just leaves me with a negative 32 on the left. And on the right side, 5x minus 4x is 1x, and then I still have my minus 25. Now you know that we want to isolate the x, so the way to isolate x here is to eliminate the minus 25. So we'll put plus 25 on both sides, and then negative 32 plus 25 is going to add up to negative 7. So now we have negative 7 equals x. Let's check that. So I've just copied my equation over, but I've replaced every variable with negative 7. Okay, now according to order of operations, we should finish the operations in the top of each fraction before we worry about simplifying or doing any dividing. So in the top of this first fraction, we've got negative 7 minus 3. So that's going to add up to negative 10, and that's over 5. And then we've got our minus 1. Now, we might ordinarily have to do a common denominator, but we're lucky here because 5 goes evenly into 10. So negative 10 divided by 5 is negative 2, and then negative 2 minus 1 is negative 3. So let's see what happens on the right side. Over here, negative 7 minus 5 is negative 12, so we have negative 12 divided by 4, and that's just negative 3 as well. So the two sides match, and that tells us that negative 7 was the correct solution. Okay, now in example 8, we've got an application, or you could say a word problem, sort of. And a lot of times people look at something like this and they just go, oh, it's going to be too hard, it's going to be too much trouble, it'll take forever, I'll never get through it. But you know, anytime they give us a word problem, we know that the examples that came before have been ones that would help us get ready for this. So we already have all the tools we need to solve this. We just have to read it and think about it for a second. So step 1 on a word problem is don't panic. Just think about what the problem's telling you, and then think about how what you know could be used to find the answer that you're looking for. So let's read it together. It says the graph indicates that people with a low sense of humor have higher levels of depression. These graphs can be modeled by the formulas shown below the graph. So here's the graph, and you can see that the people who are classified as the low humor group, their average level of depression goes higher, it goes up faster than the people who are classified as the high humor group. Not only does their average level of depression not go up as fast, it doesn't go up nearly as high either. So here are the formulas for that. This is the formula for the low humor group, and this is the formula for the high humor group. Now the D stands for the average level of depression, and the X represents the intensity of the negative life event. So let's read the question here. If the high humor group averages a level of depression of 3.5 or 7/2, same thing, in response to a negative life event, what is the intensity of that event and how is the solution shown on the graph? So let's take one thing at a time. First of all, we know we're working with the high humor group. So let's go ahead and copy the high humor formula over here. So we've got D equals 1/9 X plus 26 over 9. Okay, the piece of information they're giving us says that the high humor group averages a level of depression of 3.5 or 7/2. Now, since my formula contains fractions, I will choose to use the fraction form of this value. Now, this is the average level of depression, so this is the D number. And they are asking us to find the intensity of the life event, that's the X. So they're giving us D, they're asking us to find X. So I'm going to substitute the 7/2 in place of the D. So now I've got 7/2 equals 1/9 X plus 26 over 9. This is an equation exactly like one of the ones we solved in an earlier example. It has denominators. We want to eliminate those denominators. So we need to think about what the least common denominator would be if we wanted to get a common denominator. And it would be 18. Okay, that's what we're going to use as our multiplier. So I'm going to go through and just multiply each term by 18. So 7/2 times 18, 1/9 times X times 18, and then 26 over 9 times 18. And let's see what happens to each one. So here, 18 divided by 2 is going to reduce to 9. So what I've really got here is 9 times 7. And then over here on the right side, I've got 18 over 9. And so 18 divided by 9 reduces to 2. So I've got 2 times 1x. 2 times 1x will be 2x. And then finally, I've got 18 divided by 9 here, that's 2. So I've got 26 times 2, and I'll just write it in multiplication form. Okay, now let's do all the multiplication. So here we have 9 times 7, that's 63. And then over here we have 26 times 2, that's 52. And we just want to isolate this variable term. So we'll put minus 52 on both sides of the equal mark. And that will simplify the equation to 11 equals 2x. And now divide both sides by 2 to isolate the x. And that gives us x equals 11 divided by 2, which is fine if you want fraction form, but if you want decimal form, 11 divided by 2 is 5.5. And so that would be the intensity of the life event that would cause this level of depression. So we've answered the first question, and now it says, how is the solution shown on the graph? So let's go over here and look at the graph, and we're only looking at this line that involves the high humor group. And so what we found when we solved the equation was that a depression level of 3.5 corresponds to an intensity of a life event of 5.5. So over here on the graph, they're telling us that the horizontal axis is the intensity of the negative life event, and the vertical axis represents the average level of depression. So what we expect to see is that for an average level of depression of 3.5, which would be somewhere right in here, the intensity of the negative life event would be somewhere between 5 and 6. So we found that it was 5.5 exactly, and it sure looks pretty close to that on the graph. Okay, now let's take the same graph in the same situation and let's answer another question. So this one says if the low humor group averages a level of depression of 10 in response to a negative life event, what is the intensity of that event? And so this time we'll be using the low humor group formula. So that's going to be D equals 10 ninths times X plus 53 ninths. And this time they've given us a level of depression of 10. So they've told us that D equals 10. And again, we're trying to find X. So I'll just substitute 10 into our formula for the D. Okay, now my only denominator is 9. So in order to eliminate this denominator, I'm just going to multiply everything on both sides by 9. So multiply the left side by 9 and multiply both terms on the right by 9. Okay, that gives us 90 on the left side. And then on the right side, this 9 and this 9 divide out, and so that term will just be left as 10x. And then for the second term, the 9's divide out, and we're left with 53. And now we want to isolate x in this equivalent equation. So we want to isolate the 10x term, so let's subtract 53 from both sides. 90 minus 53 is going to be 37. So we have 37 equals 10x. Now divide both sides by 10 to isolate the variable, and that gives us x equals 3.7. So for the low humor group, a negative life event of intensity 3.7 would correspond to a level of depression of a 10. Okay, let's find that on the graph now. So we know that when D is 10, up here on the vertical axis, when D is 10, we can see that that corresponds to an intensity of a negative life event of almost 4. So it's hard to tell on the graph that it's exactly 3.7, but that's what our calculation showed. And you can see on the graph it's like really close to 4. So somewhere between 3 and 4, but closer to 4. And that's it for example 8. Now let's move on and talk about ratios and proportions. So what exactly do we mean by a ratio? Well, a ratio is basically a fraction. A ratio compares two quantities by division. So it does look like a fraction. And a proportion is a statement that says two ratios are equal. So if we have two ratios that are A over B and C over D, each of these individual fractions is a ratio. A over B is a ratio, C over D is a ratio, and if we put an equal mark between them, that equation is called a proportion. That's all we're talking about when we're talking about ratios and proportions. Now, we can eliminate denominators by multiplying both sides by B times D. So whatever your two denominators are, if you multiply both sides by the product of the two denominators, you will eliminate your denominators. In every example we've done so far, we have found the least common denominator, but it's not even really necessary to find the least one. Any common multiple will do, and so really, if you don't want to try to think about the least common denominator, you can just multiply both sides by B times D and not worry about whether it's the smallest common denominator or not. So here's example 9, and what we're going to do here is solve each proportion and check. So we're going to find the value of the variable in each proportion. Okay, so here we have 63 over x equals 7 over 5. The first thing I'm going to do is just copy it down bigger where I can work on it. And then if I just take these two denominators and multiply them together, I'll have 5x. So I'm going to multiply both sides of the equation by 5x. Now notice what happens here. The x's here will divide out because I have an x in the top and an x in the bottom. But what I'll be left with is 5 times 63 for the left side. And on the right side, the 5's cancel out because 5 divided by 5 is 1. And so that will leave me with 7 times x for the right side. Now, your first thought might be to multiply out 5 times 63, but a lot of times that's not even necessary. I wouldn't even go there, because if we divide first, a lot of times we'll get something we can simplify with. So let's go ahead and divide both sides by 7, and you'll see that on the left side, 63 divided by 7 reduces to 9. So then we'll have 5 times 9, which of course is 45. And over here on the right, the 7's cancel out. So that's where the x came from. And then on the left side, 5 times 9 was 45. Now let's check that. Let's see if that's right. So we'll replace our variable with 45. So we've got 63 over 45, and we're comparing that to 7 over 5. Now notice that both of these numbers can be divided by 9. So we'll go ahead and do that. And then, of course, 63 divided by 9 is 7. 45 divided by 9 is 5. And so the left side really is equal to the right side. And so that tells us that we found the correct answer here. And let's look at part B. Here we have 10 over x equals 2 over 3. Okay, multiply both sides by the product of the denominators. So 3 times x is 3x. I'm going to multiply both sides by 3x. On the left side, notice that the x's cancel out. On the right side, notice that the 3's cancel out. And that leaves us with 3 times 10 on the left side and 2 times x on the right side. Now, instead of multiplying 3 times 10 and getting 30, remember that we might be able to simplify first. So let's go ahead and divide both sides by 2. And sure enough, we see that 10 divided by 2 is going to reduce before we do our multiplying. So 10 divided by 2 is going to be 5, and then 3 times this 5 is 15. Over here on the right side, the 2's cancel out, or they divide out and leave us with a 1, and then our x. So we have 15 equals x. And now let's go ahead and check that. So if we substitute 15 where the x was, we'll have 10 over 15 equals 2 over 3. So we notice that in this fraction, both of these numbers can be divided by 5. And so if we go ahead and do that, 10 divided by 5 is 2, and 15 divided by 5 is 3. So the two sides do match, and therefore we know that 15 was the correct value for this unknown. Okay, here are a couple more examples, and what's different here is that we have two terms involved in some of these fractions, but I don't want you to let that bother you. We're just going to do the same thing that we did in the first couple of examples. So remember that what we're doing is we're eliminating denominators by multiplying both sides by the product of these two denominators. So what I'm going to do is just recopy my problem so it's big enough where I can work on it, and I'm going to multiply both sides by x minus 10 times x. So I'm going to put it on the left side and also put it on the right side. And again, that's just the product of the two denominators we started with. And let's see what cancels out. On the left side, the x minus 10's cancel out. And that leaves us with x times 20, which we will write as 20x. On the right side, the x's cancel out. And that leaves us with 30 times x minus 10. Now, of course, it's 30 times both of these terms. So now we need to use the distributive property to eliminate those parentheses. So I'll keep my 20x on the left side, and on the right side, 30 times x is 30x, and then we've got minus 30 times 10 is 300. Okay, now we still want to isolate the x term, so we want to eliminate one of these x terms. Your first thought might be to eliminate the 20x, but remember we try to never leave one side of our equation empty. So even though it's going to give me a negative coefficient, I'm going to go ahead and say minus 30x on both sides of the equal mark. That way neither side of the equal mark will have a 0. So now 20x minus 30x is negative 10x, and then on the right side, the 30x minus 30x disappears and we just have negative 300. And now to eliminate this coefficient, let's divide both sides by negative 10, and that will give us x equals negative 300 divided by negative 10, which is positive 30. Okay, now to check that, I'm going to go back to the original proportion and replace each variable with a 30. So I'll have 20 over 30 minus 10, and on the other side, 30 divided by 30. Okay, now 30 minus 10 is 20, so the left side is 20 divided by 20, which is just 1, and the right side is 30 divided by 30, which is also 1, and since the two sides match, we know that 30 was the correct value for this variable. And now let's do the same thing on part D. So if you want to try this one on your own, I don't see anything wrong with that. But assuming now you're ready to go through it with me, I'm going to go ahead and do that. So here we have y plus 10 all over 10 equals y minus 2 all over 4. And so what I'm going to do to eliminate these denominators is I'm not even going to worry about a least common denominator or anything. I'm just going to multiply both sides by 4 times 10. So multiply the entire left side by 4 times 10, multiply the entire right side by 4 times 10. Okay, now on the left side, this 10 will cancel with this one, and that will leave us 4 times parentheses y plus 10. Over on the right side, this 4 will cancel this one, and that will leave us with 10 times parentheses y minus 2. Now we're ready to distribute. So 4 times y plus 4 times 10 gives us 4y plus 40. And then on the right side, 10 times y minus 10 times 2 gives us 10y minus 20. Now we're in a situation where we have y terms on both sides of the equal mark. In this case, because I have a variable term and a constant term on each side, I can choose to keep the y coefficient positive if I eliminate the variable term with the smaller coefficient. So I'm going to put minus 4y on both sides. That's going to give us 40 equals 6y minus 20. Now I want to isolate the y term. So I'll put plus 20 on both sides. That gives us 60 equals 6y. Now divide both sides by 6 to isolate the variable. And that gives us y equals 60 divided by 6, which is 10. And now let's check that. So if we substitute 10 back into the original proportion everywhere that we have a variable, we'll have 10 plus 10 over 10. And on the right side, we'll have 10 minus 2 over 4. Okay, on the left side, 10 plus 10 is 20. So over here, we've got 20 over 10. And of course, that simplifies to 2. On the right side, 10 minus 2 is 8, and 8 divided by 4 is 2. So they match, and therefore we know 10 is the proper value for this variable. Okay, so we are about to look at some applications of proportions. And so here I've got some steps for solving applied problems using proportions. These are just general steps to guide you to help you figure out how to set up the problem. So step 1, read the problem carefully. You might want to read it a couple of times. It is easy the first time you read a word problem to get overwhelmed by all of the details that they present you with. So read it once, then take a deep breath and read it again. Read the problem and represent the unknown quantity by X or any other letter that you like. You know, if you're looking for a depth, you might want to use D. If you're looking for the length of a side, you might want to use L. It's whatever, but I'm just going to use X here. So step 2, set up a proportion by listing the given ratio on one side and the ratio with the unknown quantity on the other side. The only thing you have to be careful of here is that each respective quantity should occupy the corresponding position on each side of the proportion. So however the first fraction is set up, that's how the other fraction must also be set up. Step 3, if you've got units involved like inches or pounds or centimeters or whatever, you're just going to drop the units and then solve the proportion the way we did in the previous examples in example 9. So they say apply the cross products principle. We didn't call it that, but basically it means eliminate the denominators by multiplying both sides by the product of the denominators. And after that, you'll be able to solve for x and answer the question that you were asked. Okay, of course we need an example here. So this is example 10. It says the property tax on a house with an assessed value of $480,000 is $5,760. Determine the property tax on a house with an assessed value of $600,000, assuming the same tax rate. So the first thing we want to do, of course, is figure out what unknown we're looking for. So remember it said determine the property tax on a house with an assessed value of $600,000. So we're looking for the property tax. I'm going to go ahead and write down that our unknown is that X is a property tax value. And now let's set up our proportion, which is going to be made of our two ratios. So it doesn't matter how you set up your ratios as long as you set up both ratios the same way. So like right here, they said that the property tax on a house with an assessed value of $480,000 is $5,760. I'm just going to use the numbers in the order they gave them to me. So I'm going to put 480,000 over 5,760. Now notice what I did here. I put the house value over the property tax value. So when I put my equal mark and I build my other fraction, it also needs to be house value over property tax value. So for our second ratio, the assessed value of the house is $600,000, so that number needs to go in the top. And the property tax value that we're looking for, that's the X, that needs to go in the denominator. So now it's really important that you understand that both of these fractions are set up as assessed value of the house over property tax value. Could we have done it the other way? Yes, but they would both need to be done the other way. So if we put property tax in the top here, we would need to put property tax in the top here. It can work either way. It does not matter which way you do it, but it does matter that you do both fractions the same way. Okay, now that we have this is our proportion. The way to solve it is to multiply both ratios by the product of these two denominators. So I'm going to multiply both denominators by 5,760 times x. Notice what happens on the left side is that the 5,760s cancel out, and we're left with 480,000 times x. On the right side, notice that the x's cancel out, and we're left with 600,000 times 5,760. Okay, now we do not actually care what this number is. Do not take your calculator and multiply that number out because it doesn't matter. What we want to do now is isolate our variable. So we're going to divide both sides by 480,000. The 480,000 will cancel from the left side, and all we have to do to get the value of x now is multiply 600,000 times 5,760 divided by, that's what the fraction bar means, 480,000. And when you do that on your calculator, you'll find that x is $7,200. So the property tax for a house with a value of $600,000 would be $7,200. Okay, now if you wanted to check this and make sure that you did it correctly, you would want to put your 7,200 in the original proportion and just make sure that both sides give you the same decimal value. So on your calculator now, 480,000 divided by 5,760 gives us 83.333. And on the right side, 600,000 divided by 7,200 also gives us 83.333, and that's how we know that we did it correctly. So that's example 10. Now let's look at example 11. So this one says, wildlife biologists catch, tag, and then release 135 deer back into a wildlife refuge. 2 weeks later, they observe a sample of 140 deer, 30 of which are tagged. Assuming the ratio of tagged deer in the sample holds for all deer in the refuge, approximately how many deer are in the refuge. And by the way, this is a real method that they use to count populations of wildlife. You know, they can't track them all down and count them. So what they do is they catch a few of them and tag them, and they release those back into the population, and then they give them time to mix back in with each other, just like they did here, and then they catch a new sample, and they assume that the percent of tagged animals in their sample is the same as the percent of tagged animals in the population, and so they can set up a proportion that way and make a good guess as to the number of animals in the whole population. So let's try it here. Of course, the first thing we want to do is figure out what our unknown is. What will X represent? And so when we read the problem, they asked us approximately how many deer are in the refuge. So X, our unknown, is going to be the total number of deer in the refuge. And now we have to decide how our ratios are going to be set up. Do we want to put the number of tagged deer over the total number of deer, or the other way around? It really doesn't matter, but we have to decide. And so I'm just going to decide that we're going to put tagged over total. Okay, I want to start with this ratio where we know both of the numbers. So they told us that they observed a sample of 140 deer, 30 of which are tagged. So in this sample, there are 30 tagged deer and 140 total deer. So that is one ratio. And we're assuming that that's going to be equal to the ratio for the whole population. So now let's go back up here. It said that they caught, tagged, and then released 135 deer. So in the whole wildlife refuge, there are 135 tagged deer, and we're trying to find the total. So our second ratio is going to be 135 tagged over X total. So here's our proportion. So this does not look too bad. Let's go ahead and solve it. So remember, what we do is we multiply both sides by the product of the two denominators. So multiplying both sides by 140x, we can see that the 140s will cancel on the left, and that will leave us 30x on the left. And the x's will cancel on the right, and that will leave us 135 times 140. Now we just want to isolate the variable here, so we'll divide both sides by 30, and the 30s will cancel on the left, and that will leave us with x equals 135 times 140 divided by 30. So we'll just do that on the calculator, and that gives us that the total population of deer in this refuge is 630 deer. Now let's shift gears a little bit and talk about our last topic, which is equations with no solution or infinitely many solutions. So it turns out that some equations are not true even for one real number. So some equations have no solution at all. There is no number that will make that equation true. On the other hand, some equations are true for all real numbers. The equation is true no matter what number you plug in for the variable. So what happens when you try to solve one of these equations? If you try to solve an equation that has no solution, what happens is you'll end up eliminating the variable, but you'll get a false statement. You'll get something like 0 equals 3 or 0 equals 5 or whatever. But it'll be two numbers with no variable, and obviously those two numbers are not equal to each other. But if you attempt to solve an equation that's true for every real number, then what happens is you'll still eliminate the variable, but this time you'll get a true statement like 0 equals 0, and it seems like it's not giving you any information. So we're going to do an example of each kind here. The solving process is the same, because when you start out on these equations, you don't know that they're different from any other equation. It's just that when you get to the end, it feels like something went wrong. So that's what I want you to see here. So let's look at 3x plus 5 equals 3 times parentheses x plus 2. So we know that what we would normally do is start by distributing the 3. So that would give us 3x plus 5 equals 3x plus 6. Now right here, where you see the same variable term on both sides, that should always make you pause, because something weird is about to happen. If you have the same variable on both sides, you're about to be in either a situation where there's no solution or where every number is a solution. Okay, so we would continue solving here by subtracting 3x from both sides, and then what would happen is the variable term would disappear from both sides, and we would be left with 5 equals 6, which is obviously not true. And so what we have found here is an equation that has no solution. In other words, the solution set is the empty set. On the other hand, let's look at part B. So if we distribute the 6 here, we'll have 4x plus 6 equals 6x plus 6 minus 2x. And we see that we have terms that need to be combined on the right side. So 6x minus 2x is 4x. So now we have 4x plus 6 equals 4x plus 6. Now this equation has the same expression on both sides, so it doesn't matter what you plug in for x, it's always going to work. Every number seems to be a solution of this equation. And you can see that if you keep going, your next step would be to subtract 4x from both sides. But that would make the variable term disappear from both sides, and that would leave you with 6 equals 6. And that's a true statement, but it's useless, right? Like that does not tell us what the value of x is because there's no variable here. So whenever you get in a situation where you have a number equal to itself, so it's a true statement, that's trying to tell you that every number is a solution of this equation. So here the solution set is all real numbers. And so we would write that as the set of x such that x is a real number. And that's it. So you guys, this was a large section with a lot of different things in it, but hopefully some of it you knew already. Be sure and practice. Be sure and ask your instructor about any concepts that you're having trouble with, especially on those proportions. I know it's hard sometimes for students to get those set up, so don't be afraid to ask questions. Get all the practice you can, and I'll catch you guys in the next section. Bye.